Welcome back. In the last video we talked about a method to compute the greatest common divisor of a and b. In this video we'll talk about another method that's very efficient. It's called the Euclidean algorithm. Before we state the algorithm, let's walk through an example and explain why it works. Here's our example. Let's compute the greatest common divisor of 144 and 42. First step. Determine which of the numbers is larger and which of the numbers is smaller. In this case, 144 is the larger number and 42 is the smaller number. Next, divide the larger number by the smaller number. Here we're using the division algorithm that we saw earlier in this class. To do that, we need to find the quotient and the remainder. So we take 144 and we see that's 3 times 42, that's 126, and the remainder is 18 because 126 plus 18 is equal to 144. So now we look at the remainder. This remainder is bigger than 0, and so we apply the steps again. We take the smaller number and we have it take the role of the larger number, and now we take the remainder and have it take the role of the smaller number. So we have to divide the larger number, 42, by the smaller number, 18, and this time 2 times 18 is equal to 36, so the remainder is 6, because 36 plus 6 is equal to 42. And now, again, the remainder is greater than 0, so do it again. The smaller number takes the role of the larger number, the remainder takes the role of the smaller number, and we divide 18 by 6. This time it divides evenly. 18 is exactly equal to 3 times 6, with remainder 0. When you get to the end, and the remainder is 0, we have to conclude that the GCD is the last non-zero remainder. In this case, the last non-zero remainder is 6, and we say the GCD of 144 and 42 is equal to 6. Okay, so that's a method. Why does it work? Let's go back and see. Here we're going to rely on one of the rules of divisibility that we talked about earlier. We're looking for the greatest common divisor of a and b. So we're looking for a divisor of a and a divisor of b. If you have a number that's a divisor of a and a divisor of b, then it's also a divisor of a minus this quotient times b, which is another way of saying that d is a divisor of the remainder. That works for any divisor of a and b, so it also has to work for the greatest common divisor of a and b. So when we go through this method, we're calculating the GCD of 144 and 42 and reducing that to the question, what's the GCD of 42 and 18? And then we reduce that question to what's the GCD of 18 and 6, and now we apply one final divisibility rule. If one number is a divisor of another number, then the GCD is equal to the smaller number, in this case 6. So let's write the pseudocode for this Euclidean algorithm. The input is 2 integers, a and b. The algorithm defines some local variables. A is equal to the maximum of the absolute value of a and the absolute value of b. Little b is equal to the minimum of the absolute value of a and the absolute value of b. And we're going to define the remainder to be also equal to this little b. So we have a while loop. While b is not equal to 0, do the following: calculate a mod b, then redefine a to be b and b to be r, and then continue the loop. Once the loop has run its course, define GCD to be equal to a, and output that as the GCD of capital A and capital B. Let's look a little bit more in detail about what this algorithm is doing. The first line pre-processes so that little a is always bigger than or equal to little b, and that b is always greater than or equal to 0. If b happens to be 0, then the GCD of a and 0 is equal to a, and we wouldn't even use this while loop. On the other hand, if b is not equal to 0, then we need to compute that remainder, a mod b. We update the roles of the larger number and the smaller number, and we keep going until the remainder is 0. When the remainder is 0, the GCD of a and b is equal to b. A gets redefined as b, and so this algorithm outputs the correct thing. So the GCD of a and b is the last non-zero remainder. Let's do one more example. Let's find the greatest common divisor of 57 and 126. First we figure out which is the larger number and which is the smaller number. Now we apply the division algorithm. 126 is equal to 2 times 57 plus the remainder. 126 minus 114 is 12. So 126 is equal to 2 times 57 plus 12. 12 is not equal to 0, so we update the roles of the smaller number and the remainder, we see that 57 is equal to 4 times 12 plus a remainder. 57 minus 48 is equal to 9, so the remainder is 9. 9 is not equal to 0, so we update the roles of the smaller number and the remainder. So now 12 is equal to 1 times 9 plus a remainder of 3, and we'll have to do this one last time. 9 is equal to 3 times 3. So 3 is the last non-zero remainder, and we conclude that the GCD of 57 and 126 is equal to 3. All right, get some practice, and I'll see you next time. Take care.